We had some very interesting points that I would like to recap in this discussion. The first point from Chris was the size of the market in 2021, with the components being 12 billion for cybersecurity, 31 billion for connectivity, 64 billion for device and application, 41 billion for data analytics, and 56 billion for consulting. We also had a very interesting viewpoint from Tripan about the layers that contribute to that value. The real question here that we want to put together in this, and then we had the point that was brought up just recently about the fragmentation of the market. So bottom line, this boils down to an ecosystem play for all of us. If we're going to get advantage of those services and be part of it, it is an ecosystem play, and it's not just security itself being 12 billion, but also the contribution value of security in the value chain. And this is the kind of thing we need to discuss today. We have a panel consisting of Sami Nassar from Pravify, Dejan Rasul from Tata, Niraj Paliwal from Rambus, Jeff, of course, here on the screen, Jeff Shiner from Micron. And I'm going to basically introduce each and every one of those speakers with a single question related to their background. So starting with Sami. Sami is currently the Executive VP of Products at Pravify. Before that, he was the Vice President of NXP Digital Security and IC Business. And then before that, he was the General Manager of Renaissance Advanced Solutions Group. But the thing that is most interesting to me is that he's considered one of the fathers of SIM, and for his work with Schlumberger that created a group that today is known as Gemalto. Sami has a lot of experience in the hardware security space, but of course, as part of Pravify, he's now looking, growing up in the value chain because there's a recognition that the hardware and software mix starts changing. Sami, historically, there were investments being made in security, and I would like you to share your views historically, how they were monetized. Where do you see the allocation of hardware and software revenues, and how is that mix changing over time?
Thanks, Tom, for this introduction. It's always a pleasure being on a panel with you. We've done it many times in the past. So if you look at early days, the hardware security was mainly in smart card businesses like the SIM card, the bank card, the ID card. Those are the first IC that have were targeted towards mainly security type services. And it was a hardware business. And as time went by, services got, on top of them. So you started to have a little bit more software and services on top of them. Then came internet with IT security, and that mushroomed into a huge budget, in the double-digit $1 billion every year, and was not working out very well because they lacked something called the root of trust in the hardware. And we started, migration towards hardware again with you're familiar as well with the FIDO, with zero trust type architecture, and getting some trusted ID anchored someplace in the hardware. Otherwise, this whole thing is floating and you cannot protect it. And now, we're coming into a new thing, this secure connectivity. And in secure connectivity, we hope that we're doing it right. It's a balance between an anchor that is trusted in hardware that is unclonable, where we can build a very solid services on top of it. And a good example of success there is, I think the cell phone did a great job. By securing that platform, now they can do payment, they can do ID, they can do so many different things. And we should, if we do it right, and there's a lot of activity going on in this direction, we anchor the software right in the device, we will have a secure platform. And I guess a lot of revenue from services comes on top.
Well, the question is how we're going to get to share it. Dejan Rasul has been in the telco industry for 2 decades, working with SIM vendors, legacy vendors. He has lived through the days of embedding essentially credentials to low-level microelectronics. He has delivered several industry-first solutions, including the fixed mobile convergence project in the world, mobile money implementation in Europe, SIM-based NFC implementation for the Southeastern Europe, and the non-physical SIM software technology, which is a key technology, by the way, that is known today as Tata SIMware. So Dejan is the head of Tata's Global Strategic IT Alliances. And the question for you, Dejan, is historically, who paid the bill for security, for which end application, How did it vary by application? And what have been the barriers to monetization and the most typical business models?
Hi, Tom. Thanks for the introduction, and thanks for an enticing question there. So predominantly, I'm going to speak about cellular because that's where the background is. So any way you look at it, it was actually in the past, it was actually the end user who paid the bill, and whether or not he or she actually needed such level of security or not. I mean, let me give you an example. I mean, securing 10 kilobytes of payload or securing a megabyte of payload with the for example, mHealth, it was charged the same. Why? Because basically everybody in the supply chain of the device, from the device bill of material all the way up to the application service providers, they just added their markup at each stage of the device assembly, or let's say of the service lifecycle. Now, in cellular, in the past, this was primarily driven by the requirement of the mobile network operators who mandated hardware from a few selected hardware suppliers from the SIM or the smart card part of the world, per region and per mobile operator. Now, what you need to understand is that closed circle of certified hardware providers was pretty much 4 in total that took approximately 90% of the global total available market at the time. So in summary, it was a stock keeping unit was required to be managed per customer and per operator, which basically led to a very high fixed cost, which by definition means that volume is going to be limited. And at the same time, because the volume is limited and the customers are not there, the investment on the security side of things, again, is either subsidized or other ways are how can I say, modeled up in order to cover the cost and actually drive some revenue. Now in IoT, high cost is a definite no-no. And basically, if you want to reach the expected levels, you need the exact opposite, right? I mean, you need to make sure that the fixed cost of actually getting the customer to connect to your service is as low as possible. And then the variable cost is where you monetize, because then you can do purpose-built services that fit that specific use case of the end customer, instead of going with a generic purpose or general purpose hardware that doesn't really care if you need that level of security or not.
All right, great. So now we're going to get to the invisible parts that add to those costs in the supply chain. Jeff is basically the director of IoT Security Solutions and the team lead for Microsoft Authenta Technology Platform. Prior to Micron, Jeff led the new product introductions ranging from the new data center solutions that became the Expansion and the new IoT devices with Expansion and Cypress. Jeff has introduced next generation memory technologies that resulted in major technical and operational advancements to the end users. And of course, Authenta platform is no exception, because it's an innovation that I personally believe has an opportunity to enable connected suppliers accelerate their own digital transformation. So, Jeff, what role have semiconductor companies played in the development of platform solutions like NFC that enable the broad ecosystem? And how do you see that change in the future? And of course, I will have some personal observations at the end of this panel.
Oh, it's interesting. I would say to first get an idea of how integration has happened in the past is important, so you can understand how things are happening going forward. But traditionally, you would have big semis that would work with different chipset partners, like a flash memory vendor working with a processor company, to maybe 5 years in advance put together the links between those devices so they can be compatible. The problem is this is really not working anymore, because you have so many different versions of security. That's another layer on top of the fragmentation. So not only you have hardware changes between different families, even amongst the given vendor of a processor or MCU or so on, that it just takes too many years to do that. So what has to happen in the future, we really feel that things have to be abstracted in a different way, at a different level. And so what we're trying to do, at least with the Authenta platform, but there'll be other strong platforms out there that really work together in an open way to have the right level of abstraction layers, so that there's a way that a general attestation to the cloud might work, or a way that you would bind a registration. In these these open platforms need to be created and driven cross industry, and you need leaders in the industry that know how to really guide the rest of the vendors who maybe don't have the resources to go drive those platforms.
The next introduction is to Niraj Paliwal, who is the Vice President and General Manager of Rambus Security and Semiconductor IP products that protect over 9 million customer devices annually. Niraj has over 20 years of experience in computing security, NXP, IBM, and Intel. As the Vice President of Engineering at NXP Security and Connectivity Business Unit, he led the major OEM design wins for NXP's NFC-based secure payment platform, which was the main use case of combining hardware, software, and application, three distinct technologies that usually come from different places in the supply chain. Niraj is now leading the transformation of the security IB business through the easy to deploy technology to secure the semiconductor infrastructure end-to-end, from data at rest, data in motion, provisioning of devices, and of course, the key management services infrastructure. Niraj, can you share your experience in deploying the triplet hardware, software, apps, platforms across, domains, including the challenges, barriers, and opportunities in the supply chain ecosystem?
Hello, everyone. Well, at Rambus, we are a technology provider. So we work with different diverse set of customers. So for example, we could be working with OEMs, or we could be working with embedded businesses like the one Authenta has, or we could be working only at the chip level. So for us, it's really important when we are inserting, let's say, a root of trust in a chip, it has the right software ecosystem and hooks and API, whether somebody wants to do a bare metal or Zephyr-based implementation, for them to later on use the secure subsystem in combination with the software, not just the firmware, to build and deploy secure applications on it. It could be very simple firmware over-the-air update, or it could be something that goes beyond in a TPM or an automotive-based HSM functionality. And this is within the chip ecosystem. As you go beyond on the supply chain and key management, for example, some of the OEMs where we supply this technology, our root of trust goes into the chip, and then our enterprise software actually provisions their chips with their workload in the manufacturing workflow. And from there, they can also do management of their features and other things on the app side. So all in all, when you look back, it's really securing the semiconductor infrastructure, whether it's at the chip level, or it's at provisioning, supply chain security, or it's key management, where you provide value-added services in the field. So it's very important for a technology provider like Rambus to be able to work with new companies and startups. Let's say my colleague from NXP, Sami, is on here. If we want to collaborate there, so how do we work with their stack? Or if Micron wants to move on to virtual SIM, how do we work with that stack? So it's really ecosystem play for us as a technology provider.
Thank you, Niraj. We're about 5 minutes late, so we need to tighten up a little bit the discussion. Jean-Christophe Ticheri was, until recently, the head of eSIM at GSMA, where he led the successful delivery of eSIM global standard. And that global standard is pretty much in every new mobile device. Previously, Jean-Christophe was the Vice President of Strategy Business Development at IDEMIA Telecom EU, focusing on machine-to-machine and automotive applications. Before that, he was the head of product strategy and management for SIM Orange Group. He has very deep expertise coupled with a broad market experience and a strong professionalism, which are key assets that he now is offering as a consultant. In other words, he's focused in the $56 billion market segment, which is the second biggest one. Christophe, can you share your views of past, present, and future of SIM, including the evolution of eSIM and eSIM benefits for provisioning and post-manufacturing?
Yeah, that's hi everyone. Thanks for inviting me. It's a broad question for a short time. So let me try to focus on what is essential. So 30 years ago, more or less, the SIM card became the token to activate a subscription in the network. and the market was happy with it. So basically, the only product that was connected was a phone or then a smartphone, and everybody was happy with it. So this started to change when some other product came to market and needed to be connected. And here I'm thinking about cars, and I would like to share a little story. So I visit that car part maker in Spain that was doing some modules for the car industries, and they say so we have three problems. First, we have a technical problems building the modules, because the SIM card that we are putting in the modules, first they don't deal very well with vibration, and they don't deal very well with temperature change. And the other thing is we have as a problem is logistic. So come with me, and he took me in a room, and there were people working with boxes of SIM from everywhere around the world, putting the SIM in the right module to go in the right country for the right manufacturing. And they say it's a nightmare. So that's where it started, and the real enabler for the remote SIM provisioning was the first Apple SIM in 2009, where Apple said, now I want to activate my devices post issuance. So the GSMA at that time started a project with a focus on machine to machine. I have a short presentation after this panel session where I give more insight, and then GSMA worked with the ecosystem to deliver a specification that basically focus on machine to machine. I'm specifically not using the word IoT because I think IoT is a cross segment between M2M and consumer. And in 2014, bang again, Apple came with a new Apple SIM, and then we have worked as an industry together to deliver the consumer version. So I think the beyond remote SIM provisioning, I think eSIM is a silent revolution. And it's a silent revolution that brings a great value, which is the capability to provision post-issuance a product. And that's the essential part, I think.
Merci, Jean-Christophe. I will have to apply a 30-second limit in the next quick feedback. Sami, can you share your perspective on SIM history and what made it successful and what is the future outlook? 30 seconds.
So the SIM main objective was to have a trusted subscription identity that can be trusted by several operators to enable roaming. That identity should be unclonable and should be independent from device. That type of quest is still there. If we can implement it in a different form factor, it would be successful for many other industries.
Perfect. And Sami, can you share your perspective on the history, SIM history, and what, Niraj, can you comment on where do you think the future will be in combining hardware, software, and apps in SIM applications?
Yeah, so I believe for this, if you look at it from industry point of view, if you take a step back and look at NFC and secure element related things, the real adoption came when payment as an application became prominent. In a similar way, the way we look at Authenta architecture, the way we look at this whole ecosystem building, I think the SIM and the virtual SIM could be that what for NFC was the payment. So I truly am hopeful and I'm really excited about that being the use case, the key use case here as we move forward. Keeping it 30 seconds.
Thank you very much. Dejan and Jeff, since you're at the two ends of the spectrum, both the root of trust and the monetization point, perhaps in the interest of time, we'll continue to the main theme, which is fundamentally how do Micron and Tata, along with the partners in the middle, specifically Rambus and Privafi, can change the monetization paradigm for the value chain. And just to frame it a little bit, there is two phases to this. The short term, which is fundamentally device services, ability to monetize device services by closing the supply chain gaps that we're going to talk about. And the longer term, which is the ability to participate in application services after the devices have been securely onboarded and they can start producing and sharing data. So starting then with the important part of how do we monetize on the short term, we want to talk about three end applications, going back to what Rick said, that you have to start from the end application. You cannot basically address the ecosystem fragmentation if you don't look at it from an end application point of view. But one of the challenges that I'd like to put to the panelists here is that if we look at three different applications, what are the common denominators that we can actually put an end-to-end solution in the supply chain? First one is utility smart meter. Dejan, kick it off. What do you see that application being? Who has been done, has been monetized, and how do we work backwards all the way to the root of trust, connecting the chain among the individual components? Dejan?
Yeah, thanks for that. That is a tall order to deliver in terms of the answer, but that's why we're.
Oh, you've got 30 seconds, by the way.
I've got, okay, thank you very much. Even bigger of a challenge for me. So I'll just, let's start with the end application. You got the utility company, they would like to deploy either digital grid or they would like to optimize a part of their grid, or not have to send people out to read the smart meters, but get that as well, predictive maintenance, et cetera, et cetera. What they need is they need a next gen smart meter for that, which will probably use Wi-Fi and will probably use cellular. I mean, either or of the two technologies, right? And for that, he goes to his ODM or OEM as the system integrator as well. And he says, this is what I need. This is the regulation. I'm in this country. Make it happen for me, please. In order to do that, they will then request and start assembling the bill of material, which will include a wireless module. It will include a SIM or an eSIM with a slot or an MFF2 embedded. Then it's going to go down to the raw materials, et cetera, et cetera, et cetera. The common denominator here was always going to be the eSIM, and was always going to be the SKU that is created. So similar to what Jean-Christophe was saying, it is the same problem everywhere, right? If you've got a SIM slot, and if there's one OEM, what they will do is they will stock SIM from everywhere in the world because they would like to have a common hardware reference design, and then just chuck the SIMs in, right, per country in order to test. Then they will send them onwards, check them out, send them onwards for the system integrator to do their work, and then these will get delivered then. The whole while, what you're doing is you are burdening the whole supply chain with the fact that you have to have a mandated service from a mandated MNO, including the mandated hardware for that region.
Okay, can we work backwards now from Privify to Rambus to Micron and understand now what are the value add components that enable essentially certain benefits, both from an OpEx point of view and also from a simplification of the value chain point of view? Starting with you, Sami.
So if you're talking about smart meters, right, at this stage, so in the smart meter space, the main advancement here is the meter can generate money, because if you have solar, if you have some type of energy generated locally, so it's an equivalent of paying your bills. So that's something that needs to be at a little bit higher level of security, independent from the connectivity technology to it. So the security in the meter needs to be up to be able to do reverse the count, and if you have local generation of energy. Second one, and this is Dejan touched on that, the connectivity. So you have different type of connectivity in today in use. Drive-by is one of them. People drive by and collect the meter level value. You have remote, but most interestingly, a lot of people like the analytics around it. You can see how much you're using dynamically. So those are value-added services that are just being in complement to the basic function of a meter that just read how much you consume. So you created a money-making machine for consumer. If they can hack it, you can create a data analytics and an interface to optimize their usage and have a better experience. And those require security. And security, we believe at Privify, needs to be independent from the connectivity technology that's going into the meter itself.
And Niraj, what do you think the contribution of KMS is in that value chain in alleviating some of the challenges associated with complexity and OpEx?
Yeah, so if you look at the Authenta security model, it combines trusted provisioning in manufacturing with the post-manufacturing security and the identity assurance. That's basically identity assurance, or the KMS, is addressing a critical need that is fundamental to unlocking the value of IoT. If you look at supply chain integrity, if you look at how exactly in-flash root of trust combined with KMS and security SaaS can really provide the value. So KMS sits in the middle of it, between the Authenta root of trust and the SaaS offering that has. So that's kind of the enabler, if you look at from that perspective. And that's how we enable the value.
Thank you, Niraj. And Chris, now we're going to basically put the platform together. So fundamentally, it's not just about the root of trust inside Authenta, but also the capabilities connecting with the three partners to deliver an end-to-end solution. So can you actually comment about that? What is the fundamentals of basically providing economic value, and how do you see that scaling in the future?
Sure. So I like to think of Micron's position here, and I think a lot of the semiconductors' position is you have to stay at a platform level, and we have to look at things that are easy to deploy on one side, because one of the main roles for any semiconductor is that we're in general going to be the companies that enable OEMs and designers of platforms. And the service partners, and a lot of the problem of the past has been service partners had no way to get access to that channel, the ability for design, implementation, and test in a very simple way that could deploy something later on. If you go to the consortiums, you would listen to all of the different discussions about the different points in the life cycle of a device. Those pieces of the life cycle were not talking to each other because you had different companies at each point. So an effective platform has to be built with the entire product life cycle in mind. And it has to start with that massive shift left, bring in the provenance of trust of that device when we manufacture the silicon, and then extend on to that first point in time to first start an as-a-service model for whoever that is. It could be the stronger firmware developer, it could be much, much later, but it has to be flexible, and it has to stay at a platform level, and it doesn't dictate other technologies and how they take and implement that, because we want to facilitate lots of partners, lots of new great ideas to really deploy devices stronger with a better zero trust model, and allow those policies that manage in the cloud to really get creative and manage devices of all types. And so I think those are kind of the ingredients that we're looking at here, so that the service can spin up anywhere at any time, and new subscription models get to take advantage of that.
Let me see if I can actually try to summarize what I think I heard from everybody. So first of all, today we have the chip supplier like Micron, and we have the OEM that basically builds a system which relies on a SIM. And in building, testing, and deploying that system, they have to essentially have a physical SIM, which actually adds overhead. The MNO basically also has an overhead on the SIM relationship that he has to build between the OEM and the end application provider, being the utility company. There may be a system integrator that also has a high cost of delivery, testing, and the manual bulk and mass onboarding. And of course, the end application provider has a cost associated and complexity associated with that essentially adds up when it comes to deploying and fleet monitoring, management, and maintenance. All that adds complexity to everybody. And what the platform solution enables is to tie a root of trust to what we call a virtual SIM, in lack of a better word, that can be used to develop, test, deploy before the actual point of onboarding in the supply chain. Is that a fair assessment?
Yeah, I would say so.
And that eliminates complexity in the supply chain. That eliminates a lot of OpEx, all right, to everybody. And at the end, every partner participates at the point of deployment, which is the point of monetization, which is onboarding the device and then turning the cellular service on. How is that going to be monetized is also a partner issue. With that, let's see, because we're running a little bit of time, can we find a common, is it fair to say that an automotive use case and an industrial tracking use case, we have a very similar situation? And would there be some differences that you want to highlight, Dejan?
No, it's exactly the same problem, and it will be exactly the same issue. What everybody needs to understand is that an application service provider versus the OEM or somebody who's building the device, the point is they've got 4, 5, 200 MNOs in the mix globally if they would like to deploy a global service. Per that MNO in the past, there was an SKU that needed to be managed. And that is across all use cases, that was always the issue. With a physical SIM or an eSIM in the supply chain, this was always an issue pre-actual commercial deployment. Okay.
Great. So fundamentally here, we have the fundamental platform concept, which is how do we put the pieces together into a virtual deployment solution that essentially takes the burden away from the supply chain and adds value to the participants in the ecosystem. I'd like to move to the next phase, which is take that concept, which is today for physical SIM and cellular, and move it to any application market that is not cellular, and it can be used to any root of trust and connected with KMS solution, connected with the security service stack, all the way to monetization. And perhaps the team here can comment about how the platform should have to evolve and what is the ecosystem collaboration that is needed. Sami, you want to start with that a little bit?
Yeah, so the core of this whole thing, if we can enable a trusted root of trust with on top of it something like a micro edge, where you can implant a SIM card or some other connectivity ID, you solve the whole problem. The SIM subscription or the SIM card is just a subscription towards cellular communication. If that is trusted to be embedded in any chip, basically in any environment, just because you were able to provide this anti-cloning and secure provisioning capability, you're good to go with a lot of devices. So you don't have any more constraint. And there's one thing that I want to point out. You pointed us towards it, the difference between auto and industrial. They have different standards, right? They have different temperature range, different conditions. They are different chips. So right now, there's a lot of concession by putting like the SIM card in one or the other. And this is maybe why it didn't make it too much in the industrial space. If you can embed it in an industrial chip, that's a very different equation. You can have that, much more, readily available. So moving the SIM into an abstracted module, abstracted software or cluster or whatever you want to call it, and being able to embed it into a hardware environment remotely is an extremely powerful proposition.
Great. And, in doing that, Jean-Christophe, obviously, there's a lot of experience that we've built through the, EUICC, et cetera. And can you comment a little bit about the general concept of EUICC and how it could be applied in that particular paradigm?
I think in general that the work that has been done in GSMA is not only to bring the SIM as an eSIM and just bring the subscription. The eSIM as we know it will bring much more than just a subscription. First, there are some initiative bringing root of trust and trust and security to the end-to-end security SIM-based, and that's IoT Safe. It's an initiative that's definitely bringing that. There is a secure application for mobile that also allow remote provisioning of application in the SIM outside of the operator profile. And that's another value proposition that I think is essential. And that's more for service. The integrated EUICC initiative is also one important one. We know that scale and cost are essential, and integrating the SIM function inside the chipset will bring additional value and reduce costs. So this platform is just more now than ever, potentially more than a subscription enabler.
Thank you, Christophe, Jean-Christophe. And Niraj, maybe you didn't see that, but there was a very interesting slide by Tata that said the value edge stack distributed across components is an opportunity to essentially connect the value stack and see if we can potentially create a chain for monetization. So the question to you is, how do you create an agnostic platform bridging among the root of trust and the different protocols that would need to be supported in a wide variety of users in the marketplace?
Yeah, so when you talk about this platform that's agnostic, let's take a little bit look at how is this fragmented. If you look from the traditional point of view, only on the secure hardware, you have common criteria, you have TCG approach, then on the certification side, also on the FIPS, ISO, ASIL certification. There's just so much going on around this whole area on the hardware side that most technology providers end up spending more time and money on solving that problem. And it's getting more complicated. When I try to sell a root of trust, it's got to be ASIL B and D certified, ISO. Then we're starting to look at, there are two new frameworks emerging. One coming from the cloud companies like OCP Security, Cerberus, and some of those. And of course, we all know OpenTitan. The other one becoming more lightweight common criteria. So for example, NXP is going in CSIP global platform approach. If you look at someone like Rambus, what we end up doing is, we end up going back to the applications. Is it secure boot? Is it over-the-air update? Is it TPM functionality? Is it the HSM functionality for automotive? Is it a secure element that probably acts more UICC, like a virtual SIM kind of functionality? So the approach we have taken is to move that functionality above firmware in the secure applications. And I believe in that way, whether it goes via global platform route or it goes via some other industry standard route, when you move it up to secure applications, you can create a platform that's agnostic, and we can actually serve the largest memory maker as well as OEM or a disti, all three with the same software stack. And my colleague Joe and Barry would be on the virtual session. We're really excited about the CMV3. That's the third version of our crypto manager provisioning platform that includes key management as well. That is built to be agnostic for platforms as well as for diversity of customer use cases.
Well, that must be music to Dejan's ears, because he's doing SIM today, and he probably wants to apply his onboarding and provisioning solutions to different application markets. So perhaps, Dejan, you can tell us a little bit how this could, moving up to the application level, as Niraj pointed out, what would it mean in terms of you expanding your platform for monetization and increasing your ecosystem?
Well, I think it's obvious that as long as we automate a lot of the processes in terms of onboarding and then helping through the ecosystem to bridge any different connectivity and root of trust policies here, I think the automation of those processes is going to enable the application service providers or the people that are hosting those services with more recurring revenue streams that we're going to be able to benefit from. Now, what I mean here is, and Gartner agrees, that 80% of manufacturers that embed 3GPP services, which is what we're doing here, will use a partner revenue share model, up from 20% last year. So everybody's going to the root of, and also, I'm sorry, another point is that by 2023, 10% of all managed IoT connectivity is going to be delivered by those people as well. So this is all towards the fact that people want to automate the processes of bulk onboarding devices without having to stack mandated SIM, eSIM subscriptions or hardware. They want it purpose-built in terms of connectivity when they need it, as well as security when and how they need it. Okay, and that's what I believe as a baseline, Authenta and Tata and this ecosystem are delivering.
Well, Jean, it's actually so much easy for you to talk about that being on the top of the value chain, monetizing. The headache is on Jeff here, all right? So because he's got to orchestrate the entire platform for the value chain. So this is now where I will allow Jeff to, Shiner, to go a little over the presidential debate limit. because he needs to explain to us how he's going to put all that thing together with, for the supply chain, the identities, the trusted process, the connectivity models, the policies, the device trust, all those things have to come together. So Jeff has to think end application inward to put all that together for this ecosystem to work as a real partnership platform. Can you comment about that, Jeff?
Sure. Thank you. So it's been a journey with Authenta. Authenta was developed actually years ago with our first silicon with the intent to be more of a platform hardening strategy for, think of a self-healing BIOS and something that could bring a platform back to good if things went wrong, but do it with a hardware root of trust. It's morphed from a device-centric technology now with the KMS at its back with that trusted authority, that now it offers the deployment mechanisms necessary with all the access control that a device needs, and then initiates and controls and allows these partners to actually do over-the-air updates to deploy at new times, but then to attest back and to validate from the trusted authority when that device needs a service verification. And so with Tata, we see this as a true global footprint because of what Tata has brought to bear in the market with all of their fiber around the world. Not much IP traffic doesn't run over Tata fiber. And so this true global footprint is we feel a global silicon footprint with flash memory, probably the most standard semiconductor in the industry. And it can cover all of the life cycle from when firmware needs to get put on and set up that image that can do these new things, whether it's a cellular or whether it becomes LoRa or something else new. Things can just get registered. It can go so far out in time as to help a container that's about to deploy and run some special new thing through a containerized workload that'll enable all these Kubernetes platforms to have the control they need. So it scales. It scales not just to the onboarding, which is where most companies are now, but it scales into the use cases that are coming down the pipe. And then that'll scale well into the analytics that everybody's trying to find ways to monetize the data that they have access to. So
we have to think about your customers a little bit and what it means about their design methodology, because today they order a chip from you, they built a system, all right, and then on the top of the hardware, we're going to add the OS and the applications. So they have to change the way they think about the end application in order to be able to do that and take advantage of secure locations and containers and secure functions and enclosures. How, what kind of recommendation you would give to your customers in doing that in architecting their end their systems from an end application point of view?
Well, and that's where the ecosystem comes in too. So it's a time to get creative, because now you have two things happening. When the semiconductor shifts left and enables something much earlier, you get to merge points in time to take OpEx out of supply chain. Less audit because maybe you have control. That means new services can build new things and deploy differently. But the ecosystem partners now get to shift their mindset left, and the platforms that are being built that are like communication platforms, they also get to shift left because they have roots of trust they can trust in a different way and at a different point in time. So it is going to be a learning, because lots of new things will come to bear. But if you understand that the framework that we're driving with Tata on this cellular solution is truly global because it's been built at a platform level because of that change, it's that reference architecture that gets to be leveraged now for many other use cases.
Okay, we have very little time left, and I want to leave a little time for questions. So today we really experienced a thought leadership example by Micron and its partners, including Tata and Rambus and Privify, of an end-to-end solution platform that can enable monetization for all the value-add parties. I would call it the mini ecosystem platform, and it shows how chip suppliers, OEMs, and CSPs, cloud service providers can benefit from the ecosystem IQ. That is, by the way, without trying to advertise, a little self-serving here, the main idea of the Global Semiconductor Alliance trusted IoT ecosystem, the thought leadership that starts from the end application where people collaborate to develop and define use cases for end-to-end solutions, something that we started with Sami. So, Sami, you want to comment on that?
Yeah, so we co-founded this alone. I was NXP and you from Siemens side. And I'm happy what you're doing with it now. I did chair it for some time and gave you the baton, and now you made it called ties. And actually, this is very important because there's another one that NXP Siemens did, which is the Charter of Trust. And Tom, you were involved in that too. That was a top-down approach of how cybersecurity needs to be taken more seriously in the infrastructure, on the digital economy infrastructure. And Siemens have a lot of platform approach to their product versus selling boxes or machines like they used to do, and you're very familiar with that. So what you did and what we in ties here and what the GSA is doing is a bottom up. It's like, okay, you have the CEO signed in the Charter of Trust that we will build the cybersecurity into our infrastructure. Now, how do we do that? And I think ties does provide a pretty good guidance towards how you implement bottom up what is a trusted digital economy. It's something that is rooted in hardware, with layers on top of layers that can constitute a trusted system. So I'm a big proponent of these movements.
I appreciate it, but we all know that in order for that thing to scale, you have to essentially accelerate in an accelerated fashion. You have to bridge OEMs, cloud service providers. Everybody's got to come to the mix, and it becomes a collaborative ecosystem platform solution, synergistic. So whether this is top-down Charter of Trust, bottom-up GSA ties, all those ecosystems have to come together using the example that we built together. But there is an evolution, and the evolution is starting with thought leadership innovation, like we saw today from Micron. Then it continues to transformation. Then it broadens to platformation before we start scaling the whole ecosystem.